day, my name is Shasmita Lakshmi Murualikaran. Today, me and my group would like to conduct experiment centrifugal force.
Good day, I'm Prakash Ramakrishanan.
Assalamualaikum warahmatullahi wabarakatuh. My name is SHOLEHIN bin NORDIN. I am from Group 2 for Engineering Lab 4. Okay, so the objective for this experiment, first of all, we can understand and illustrate how the centrifugal mechanism works. Second, to understand the theory of centrifugal force. And last, we can understand speed square and centrifugal force are proportional.
Today I'm going to talk about the procedure of centrifugal force dynamic balance. Okay, shall we start the procedure first? Okay, first we look at this table. Okay, we need to set up radius 0.1. The radius is okay, later I show, and the total mass is 100 grams. So, and the motor velocity only we have to change. Okay, the lift is formed as per the requirements. The radius will be 100. The weight also will be 100 grams. So this is 100 grams. Put here. So this is dynamic balancing, right? So we have to balance here. So we have the 50-50 on. We take out. We put here. And we off the leaf. So we start the radius. The radius will be 0. The answer of course will be the 0 lah. So now we are going to put a 5. The radius speed will be 5. Okay. 0.24 when the radius in 5. So we have to repeat again the same step to the tank, because the radius and mass is still same. When the radius at the 10, so this will be, the force will be 10.96 lah. Okay, so we should repeat the same method, same steps until the 30. So now we go into the start. When we press the two buttons at the same time, it will be stopped. Okay, so we go for the next experiment. The next experiment, the speed radius will be the 30. The radius will be 100. Okay, only the mass, the weight only will be changed. Okay, for now, the first mass to 20. So we take 21. This is 20. So radius will be low. When we move to radius, this motor, the velocity, the force if get in negative, so it will be wrong. So we have to change. We have to stop first. We have to stop first. Then changing here. The radius per speed will be in 30. Okay, when the radius per speed in 30, the force, the actual force we will get in 1.78 force. So this step will be changed. This step will be changed by this mass, difference of mass. For example, so next one the 40. So we took 40 for one and we took the two pieces of 20 gram. And next 60 and 30 gram. And 80, 40 gram and 100, 50 gram. So we put the balancing. So then we get the results. Now we going to stop this. We're going for the third experiment. Okay. As per the lab sheet for the third experiment, the speed of radius 30, the total mass 100 gram. So the radius will be changed. So where is the radius? Is the radius. The 0.02 is 20, the 0.04 is 40, 60, 80 until continuously. Okay. I'll show you for one example. 100 gram. We have to put in 0.02, so that's a 20 radius. We close the probe. See, the force will get the negative. So we have to change the boost. Like last experiment, the radius per speed will be put in 30. Then we will get the force, actual force. The changes, what the difference between last experiment and this experiment? The radius. Because last experiment we put in 100 millimeter. Now we put in 20 millimeter. Okay, for this 1.82 we will get the force. Okay, the same step will be repeated, but the radius will be changed. 20 to 40, 40 to 60, 60 to 80, 80 to 100. So that's all for this centrifugal force experiments. Thank you.
Next, I would like to explain the results and calculation of our experiment. We managed to collect the data from 0 to 30 motor velocity. This is the actual force we measured, and this is the theoretical force we calculated, and then this is the motor velocity.
From the experiment carried out in centrifugal force, it can be concluded that changing variables in our experiment affected the results greatly. The centrifugal force increased as the angular velocity, mass or radius increased. The only slight difference between the theoretically and experimental results, which was carried out by an experimental error, is between the two. Construction the angular velocity accurately was challenging due to the possibility of minor difference in decimals that will affect the readings. It is impossible for the machine to have been calibrated if it produced inaccurate readings. Things need to be taken into account in order to avoid test errors and obtain the experiment's true value. Thank you.